Hey, good morning, PracTacular home, if it's your morning. It's my morning. It's my Friday morning, actually, here as I'm rolling into the shop at Mammoth High School. So, hey, just wanted to bring you up to speed on some important things that happened yesterday in class that I didn't cover in yesterday's vlog. Woke up this morning, and I remember we had a major problem in both first and second period when we were using our cordless drill tools to bore the holes for our Romex wire through our 2x4 studs. The question was, hey, Mr. V, why does my tool smell like burnt plastic? It's all hot, and what do I do? That's a great question. Actually, it's a very important question. And so I thought today I will unpack that a little bit for us and give you some really good information. This is my jam. I geek out on tools and hardware. And so I've got articles, I've got things I can give you. But I got to teach these students why. And the short answer is, it's the physics of the tool. There's your clue. All right, hey, let me get out of here. I'm gonna show you the beauty shot today because we got Bluebird back. Hold on.
Yeah, baby, check that out. Bluebird is back. Okay, if you don't remember, for us locals, when we have perfect blue sky like this over a mountain of white snow, we call it a Bluebird Day. So, welcome to Mammoth Lakes. It's a Bluebird Day. Now, let's go into the shop and see what we can get into here.
All right, so I got to get some prep done here, but kind of following up on that whole idea of, hey, why does the tool smell like burnt plastic? It is a question that we need to know as home DIYers for sure, but as high school students, we're going to need to understand it as well, because it's a physical thing. It's the physics of the tool that is causing the problem, and I'm going to explain that today. So I'll explain it to them, and then I'll explain it to you. But I'm going to put it in the form of what we call a challenge question. So each morning when we roll in, there's either one or two challenge questions that I present to the students. And the intent is, A, to get their brains engaged and to start thinking. So I give them a scenario or a photo or a what, and I go A, B, C, or D. What would be your best answer? And then I've got this beautiful app that collects that data instantly. So they're working it off of their Chromebooks, and the information comes in, and then it tallies it up, and it says 48% of them got it right. Okay. 48%, it's not high enough, so that tells me I really got to teach this particular topic. That's my thing. So we are able to adjust during the day, who's sitting in the seat, where their brains are at, and I get a really good read on where they're at. So that's what I'll do. Challenge question, so I'll pose it back to you guys. Are you smarter than a high schooler? That's something I did a few years ago, and I'll just start doing it here as part of the vlog because it's kind of fun. So stay tuned. I'll pick you up after class, and we'll see if you can answer the question correctly. Right out. Later. All right, welcome back, everybody. Had a great day again. This has been 2 in a row, which has been super fun, both with our level 1 and level 2 students. So, but I want to follow up on what we were talking about in regards to our tools having a problem yesterday that we had to solve today. And the solution came in the form of 2 parts. One, we have to change our actual techniques or methods in order to save the tool, if you will, because what happened is we overheated our cordless tools. In particular, it was this one right here, make and model. Impact driver, hammer driver, a couple of different names, but it is a compact tool that allows us to install different kind of bits and drivers. This particular one, we were using it as a drill mode for our large bit that we were drilling through our 2x4 studs in order to run our Romex wire. So the challenge was, this tool is a hammer tool, so it's designed to drill, but not necessarily to drill for long periods of time. So we've got some science that we had to talk about. And so what happens with the duration of time that we're asking a tool to do a certain function, and how does that impact the actual motor that is inside this little housing right here? Well, what happened is it heated up to a point where we started to smell warm plastic, which is an awful smell, no matter if you've tried it or you haven't. It is awful smelling. It's actually toxic, so it could hurt us. And so the situation that happened, period 2 right over there, was it actually overheated to a point where the student actually said, and I quote, "We saw a little puff of smoke come out and then it smelled really bad." Okay, 2 physical evidence signs that are really bad, and so we had to investigate. So I went over, and yes, indeed, the toxic level was rising, and this tool obviously was the source. So we immediately stopped everything. We opened up the double doors right there. We opened the doors on the cross vent, and then we put a big industrial fan on the floor that we have, and we vented everything out, and within a minute or 2, we were clear and safe. But it made a very important point. Why in the world do the tools start to smell when we're using them? That doesn't seem right. Well, today we're going to answer that. So I'm going to take you back to the teaching area here in a minute and just kind of go over some of the educational information that I was given to our high school students. So, but wanted to demonstrate, because this is pretty straightforward with this tool, that combination of fitting will lock into most impact drivers, and that allows you, again, to quick exchange the bit. You slide the collar forward, and then it releases the bit. You push forward, and it clicks and locks. And so it's a good use of this tool, but maybe not this tool in particular. So here's what it looks like. We need to drill right in the center of our 2x4 stud to run our Romex wire. So we bring this tool in, and we create a center point to start the process. Now here's what's cool. That little threaded piece right there acts as a screw or a thread that helps pull the bit through the material. So it kind of creates an auto assist, if you will. So it's a great function. And then those corner edges there pick up our diameter, and before you know it, we're cutting holes like this. And voila, one big old hole right there. Okay, so that's what we were doing. And they needed to make 5 holes in the location based on the layout of our electrical flow, and that became part of the problem. Period 1 used the tools, and then period 2 used the tools, and the heat began to build and created a problem with our tools. So let me take you back to the teaching area, and we'll look at why the tools started to smell bad. All right. Okay, so the challenge question today, I gave it to all of my students, all 3 periods, and it really stumped them today. So I told them, I'm going to give it to you guys as adult viewers and listeners as well, and we're going to see, are you smarter than a high school student? We'll see. Okay, so here was the question. Basically this was a direct quote from a student, literally standing right over there. He goes, "Hey, Mr. V, why does my cordless hammer driver smell like burnt plastic?" That's a really great question, young man. Here's how we're going to unpack it. So I'm going to give you 3 different possible options, and one of which, A, because we were drilling so many holes in a short period of time. That could be a good answer. B, possibility because of physics. Is this a physics class? No, this is shop class. I don't know, maybe. C, because we pushed too hard and we're drilling through the hardwood knots of our 2x4s. Okay, so those were the options I gave. And we had a 0% in one class, nobody got it right. Second class, one person got it right because they guessed. And then the third, it was 0 again. Yeah, so it was basically zeros across the board. So what would you answer? Let's talk about it, okay? Survey says, correct answer is because of physics. Yeah. What we do in here has tons of science and tons of mathematics. It's called STEM, and that's what we teach in here. But then we go put our hands on things and we build things. But the learning process to get them to understand the physical forces that we were asking this little tool to do outbid its ability to achieve that, and then it started to react. So the forces against this reacted, and what we ended up with is burning tools, okay? First question in the world of physics, right? What was the forces that were causing smoke, or what causes smoke? Heat, okay. Heat inside of tool casings are a bad thing. We don't want it. If we have that challenge, we're gonna have to figure out how to operate the tool differently. So we don't wanna drill a bunch of holes all in a short period of time. We need to drill a few, let it rest, drill a few, let it rest. Time plus pause means the temperature level won't exceed what the tool is able to do, and then we can manage the heat. That was one option. Down here, because we pushed too hard and drilled through the hardwood knots. Well, we're applying too much force, in this case forward force, against a tool that has resistance as this bit is trying to carve through whatever material. So force versus resistance creates friction and heat, and we overwork the tool to the point where it starts to smell funny, okay? No bueno. So we can, as operators of this tool, make a couple of choices or change our method in order to not overheat the tool. That would make sense, right? We could, back down here on B, we don't need to push so hard, because that's one of the first rules of a good tool. If you have to push too hard, you're possibly not operating the tool correctly, and it usually ends up with somebody getting hurt. You get hurt, the tool gets hurt, your material gets hurt, because you're forcing it past its ability to do what it's supposed to do, and something's got to give, or someone's got to give. And that's, unfortunately, but that's where you see a lot of problems and accidents and instances of overworking, forcing tools, taking them beyond their physical design, and then we end up getting hurt. Not what we want to do. Okay, so that's one solution. We can change our methods, we can improve the tools. Maybe the tool was too dull. I actually tested that too. Gave one crew an old paddle bit, which is different than this, and then another crew had a new one. And with the new one, bam, 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 they were just mobbing through everything. The crew on the other, they were 50, 60% behind the other crew, because the tool itself was not sharp enough, and the physics were not allowing them to move through the material at the same rate as crew number 3. Science, baby. Rates, time, heat, durations, types of bits, shapes of bit, types of tools. Okay, so now we switch from, we get it, okay, what do we have to do? Well, we had to literally take the tool that was smoking, take it outside, put it on a stool, and let it cool down. I let it sit there for 30, 40 minutes, went out to sea, and it was still heavy in its aroma. And all of a sudden, I think that tool is lived its life. We may have burnt parts out, and therefore it's unsafe. So I red tagged it, meaning we wrap it in red tape and we put it aside for either repair or disposal, because we don't want to use faulty tools. It's just unsafe. We don't want to do it. So, okay, we don't want to do that. Well, then I challenged him and I said, hey, let me get you a tool out of my professional kit. This is the one I use in my trade as a general contractor versus this tool right here. And I said, well, what do you think the main differences are? It's not color and shape and size. What's the main difference between these two tools? And I held them up like this. And you see one that says brushless, and the other one doesn't say anything, which is tool talk for this is a brushed tool motor and this is a brushless tool motor. There's words you don't hear every day. That brings us to topic number 2. There is in fact 2 different types of motors that go inside of most of our cordless tools. If you didn't know it, now you do. The process Old technology is the brushed motor, and I'm going to show you a little freeze frame of a video that I use, which in 2.5 minutes explains the difference between a brushed motor and a brushless motor, and it gives you all the good science and graphics and all the cool things. So I'm just going to link that in the show notes, and if you guys want to check it out, you can click on it and get the insight. But this image right here is what I wanted to show you, and that may clear all this. Oh, yeah. Okay. Wow, this computer is running slow. Okay, so this was one image. I just freeze frame it in the middle, but it's pretty clear. We're looking at two different types of motors. We're looking at it from the back, like we just pulled that plate off, and that allows us to see the physical and the mechanical parts of the tool. On the left, brushless. What we see here is a combination of green and combination of digital circuit board, and then this really clean combination of mechanical parts, and then a center shaft, which is actually the driving component that moves to the front of the tool. That, to me, if I knew nothing, looks like a solid state motor control. Solid state. Versus, I look at this one on the right, and I don't see any circuit boards. All I see are lots of big heavy metal props and parts. So this big metal ring here, center shaft, combinations of magnetic and other physical parts that when you watch the video, you'll see that generates friction inside of the actual motor housing because it is a brushed motor design. All good. There's your answer. The physics of this deal is when you have contact with physical parts and then you spin them really fast, it creates friction. Friction heats up the plastic, and next thing you know it, your tools smell like burnt plastic. So we figured all that out, and we were able to come back and understand that there's two different types of tools. And then I asked, so which one should we use or buy? How do you figure it out? Well, you go back to physics, and the real question should be, how much are you going to use this tool? Do you use it for 6 hours a day, continuously, every day, 5 days a week? Or do you use it, I don't know, 3 times a month for 15 minutes? So the science would say duration, and then what are you building? Are you just putting together IKEA furniture, or are you, there's the bell. Or are you building an outdoor deck and putting rails on and drilling into concrete and setting anchors? And so you need to ask the right question, because both tools will get it done well. There's different, again, levels of tool engineered for different tool users. That's my answer. That's what I like to say. I get it all the time. Mr. V, what tool should I buy? I go, part of it's budget. Okay, we'll get to that in a minute. But part of it is, well, what are you going to use the tool for, and how much are you going to use it, let's say on a weekly basis? Well, I do a little here and there on the weekends. Super cool. Man, that's all you're doing, you could probably work with a brushed motor and have great success. I've used these for years and years, decades before we got this new tech. So it works professionally. It'll work as a home DIYer. No big deal. Okay? You tell me, hey, I am going to start a basement remodel project, and I got to put a bunch of acres in concrete, and I got to really work hard. I got to drill down and set plates and all. I'm going to say, no, you want to step it up, because you do not want your tool overheating in 2 or 3, 4, 5 drill points. And so let's work with a brushless motor and really get you the tool that's going to meet your specific project needs. That's the answer. And then they go, well, which one costs more? Good question. We talked about ROI. And actually some students knew, which was super cool. Return on investment. So if you're going to invest in anything, whether it's a tool, coffee machine, mixer, or whatever you're into, right? You're always looking for what is a good quality item, and then what is the return on the investment? Is it personal satisfaction and super fun? Is it what? Fill in the blank. So in our case, we've been using these tools for 9 years here in the shop. 3 periods a day. We don't use them every day. It's very minimum use, and they lasted 9 years before a few of them started to burn out. That's a pretty good ROI. Let's say this tool was $100 9 years ago. That's not a bad return. Now, if you buy a brand new tool, it's $190, $210, whatever the price point is. And so your return on investment on the dollar side needs to be divided by length of time of use, what are you actually doing with it, and that allows you then to create a great decision point between function of what we're calling it to do and then budget and ROI from your dollar cents, okay? Well, I ran the numbers this morning again off of a couple of toolkits that are offered on Amazon. I'll give you the link again down below. But it was a great comparison between a brush motor and a brushless. Same combination kit, so it's a combo kit. They give you the hammer driver, the drill driver, a couple of batteries, and a charger. So it's a 4-piece kit. And so I did a quick little side-by-side. The answer is 22% more for a brushless motor system. 22%. That's not bad. With an ROI, with this, with all the other advantages of a brushless motor system, I would pay 22% all day long. Not only as a professional, but as a homeowner. Because the comma in that, Mr. V, that's me, I always like to say, buy the best tool you can possibly buy with the budget that you have. So if you're trying to make the difference of 20 or 30 bucks, and you go, but wait, I know this tool is going to perform more. And when you go into the brushless category, all of a sudden you get professional quality functions that they don't put necessarily on the lower marked tools. So you get higher quality, better function, better fit and feel. I handed this one to a couple of my students right over there, and they're like, Mr. V, man, this thing just feels great in your hand. The grip is amazing, and it just really, I like this tool. That's part of buying up into the higher range of professional tools because they're designed for us. We use them every day. You know, I like to calibrate how much money I've made with a hammer driver drill over the last 40 years. It's probably hundreds of thousands of dollars because I know how to use it and it functions. We can do everything from hanging pictures to building cabinetry to putting decks on the back of your house. I mean, everything in between, right? So this is a great lesson for all of us to understand in regards to tools and motors and keeping us safe and correct operations and understanding the physics of the actual item that we put in our hand. Those are what smart builders need to know. So I hope this was helpful. I'm going to put those links in. Now, I also did a quick little PDF sheet, okay? So I'll put this in the link too. So if you either want it or whatever, email me and I'll send this out to you so you can have a quick reference guide. There we go. It's period 5. Quick reference guide if you want it. Everything kind of summarized in bullet points and goodness. So, hey man, I just want to share, bring you good, valuable information, and I hope that was good. So today is Friday. We'll take a couple of days off. We'll see you back on Monday, and we'll continue on with our rough electrical, and they'll start pulling wire and moving things into junction boxes, and there's more to see over there on Monday. All right, guys, take care. Have a great one. Go build something great, okay?